and welcome back to our third discussion on chemistry and how it relates to biology for our survey of biology class. And in the last section, you remember we looked at how we can determine how many protons, electrons, and neutrons an atom has. Now we're going to go within those and we're going to concentrate just on the electrons, because in terms of the properties of an atom and how it reacts with others, how they form bonds, it's those electrons, and more specifically the outer electrons called the valence electrons, that we're going to be interested in. So we're going to concentrate on outer shell or valence electrons and how they determine the chemical and bonding properties of an element. So will they form a bond with another element, or will they be inert like a neon or an argon and not really react with much? So when we look at an element, the valence electrons are the outer shell electrons. So in this case there is 4, so this would be an atom of carbon, which has 4 valence electrons. Okay, so those energy shells or levels in atoms are where the electrons kind of live, if you will. So that's where they will kind of configure themselves. So the electrons stay in these shells. And the simplest two elements are hydrogen and helium. Hydrogen because it only has 1 electron, and helium because it has 2. So hydrogen is very easy to draw. As you can see here, it's 1 shell with 1 dot to represent the 1 electron. So it has a valence of 1 valence electron. Helium has 2 electrons, so there's 2 on the inner shell, and it has 2 valence electrons. Now, these I've put up there because they're the only 2 that have a full shell with 2 electrons. That makes them stable. So helium is much more stable than hydrogen because it has what we call a full outer shell. Now, the next 2 levels, the ones that we're really going to be interested in, hold 8 each. So because of that, when we get to the second and third energy levels, there's something called the octet rule. And the octet rule says that atoms are stable when they gain or lose electrons to get an outer shell of 8. And the only exception to that is going to be hydrogen and helium, which when they have an outer shell of 2, they're stable. So in this diagram here, we can see, here's hydrogen, which we saw before. So here's its 1 electron, and you can see it has the potential to hold a second electron. So the white ones here are electrons that are not there, but it could hold. Carbon we saw before in the very first picture, and we said that carbon has 4 valence electrons, but it has the potential to hold 8 because it has that second energy shell, so it can hold up to 8 electrons. Nitrogen, which has 1 more electron than carbon, has 2 on the inner, 1, 2, but it has a total of 7, so it has a valence of 5. There's 1, 2, 3, 4, 5 electrons on the outer shell. And finally on this picture here, oxygen has a total of 8. There are 2 on the innermost shell, and that leaves a valence of 6. There's 6 electrons, 6 valence electrons. It actually has a valence of 2 because it can form 2 bonds, but in terms of valence electrons, it has 6. 1, 2, 3, 4, 5, 6. And it has the potential to hold 2 more. So that's how we go and find valence electrons. It's going to be very important when we talk about bonding and how they react with each other. So here's a quick diagram that goes through. So lithium has 3 electrons. I think I'm going to change that to red. 3 electrons, and we can see there are 2 in the inner shell, and it has a valence electron number of 1. So there's something called the Lewis dot diagram. So that's how we would show lithium. It has 1 dot because it has 1 valence electron. Beryllium has 2, so there's 2 dots. Boron has 3, carbon 4, nitrogen 5, oxygen 6, fluorine has 7. And neon, 1 over, is part of what we call a noble gas, and it has its 8 electrons already, so it's stable. So it has reached its octet, and when we talk about the octet rule, that's what we mean. atoms are going to try to get to a state where they have 8 electrons in their outer shell, unless it's the first shell. Okay, now, real quick, here's how we can find the number of valence electrons. So the transition metals. So this area right in here, we're going to ignore for right now because the number of valence electrons can change. And so what we're going to look is we're going to look at the columns. And interestingly enough, and lucky for us, there are 8 columns. And those 8 columns correspond to the number of valence electrons. So if we start on the left-hand side, every element in that first column, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, has 1 valence electron. The second column, they have 2 valence electrons. Now, if we skip the middle, we can go over and then we just keep counting 3, 4, 5, 6, 7, 8. So if we pick the third column here, boron, aluminum, gallium, and all the others have 3 valence electrons. And then we keep counting over. When we get to the noble gases, they already have their 8, so neon, argon, krypton, xenon, radon are all stable. And if you look at the bottom diagram here, I'm not going to spend too much time on it, but it shows the Lewis dot structure of the same thing. So we can see everything in the first column has 1 dot. Everything in the second column has 2 dots representing 2 valence electrons. Again, we skip the transition metals. We go over to 3, starting with boron, 3 dots for 3. By the time we get to column number 6, oxygen, it has 6 dots to represent 6 valence electrons. So now you should be able to take a periodic table and any element you want and tell how many valence electrons, how many outer shell electrons it has. And that's where we'll end for today. And like most of my jokes, this cat got no reaction.